Hello, and today we're going to be talking about the elasticity of demand. We're going to have two parts, part one and part two, but we're going to talk about part one right now of elasticity of demand. And let's define some criteria with this. The elasticity of demand is the most important criteria used by economists to analyze the demand function. Now, it is convenient to write the demand function of f in the form of x is equal to f of p. That is, we will think of a quantity demanded of a certain commodity as a function of the unit price. Now, since the quantity demanded of a commodity usually decreases as its unit prices increases, and the function of f is typically a decreasing function of p. Let's look at the graph for a second. Here we have figure A, we have a simple demand function. Now, remember we went over in calculus the first part of the derivative? We talked about the difference quotient. Remember this similar setup in classes several weeks ago? However, look at this very closely. We have f of what? P plus H is the quantity demanded when the unit price increases from P to P plus H in dollars. Now, as this, of course, as P increases along the X, right? Well, our demand function, what? Our demand decreases. So as the price increases from what? P to P plus H in dollars, this decreases. So that's what that's saying. So suppose the unit price of the commodity is increased by H dollars for P dollars to P plus H dollars, as we see in figure B. Then the quantity demanded drops from F of P units to F of P plus H units. A change of, see, F of P plus H minus F of P. Remember that? It's setting up the difference quotient. And the percentage change in the unit price is, here we have H divided by P times 100. So this is the change in unit price over the price P times 100. Now, in the corresponding percentage change in the quantity demanded is 100 times, look at this is the difference quotient. It looks like that, doesn't it? F of P plus H minus F of P divided by F of P, which is actually the change in the quantity demanded over quantity demanded at price P, what, times 100. Now, one good way to measure the effects that a percentage change in price has on the percentage change in the quantity demanded is to look at the ratio of the latter to the former. Now, we find that the percentage change in the quantity demanded over the percentage change in unit price, see, this expression, we're trying to derive something here. And you're going to see in just a second as 100 times what? F of P plus H minus F of P over F of P over 100 times H over P. Now, that H is being replaced by F of P, as you noticed here. And as we continue on to simplify this expression, we see that if f is differentiable at p, then this is the expression that we'll get right here in this line. See, f of p plus h minus f of p divided by h is approximately what? F prime of p, right, as you see. Which h is small, but if h is small, then the ratio looks like this. F prime of p divided by f of p divided by p, which is equal to what? P times f prime of p divided by f of p. Now, the negative of this expression right here, the negative of this expression, p times f prime of p divided by f of p, is called the elasticity of demand function. It's the elasticity of demand function. That's what this is as a negative expression, which in terms, as we go up here, E sub p is equal to negative p times f prime of p divided by f of p. Economists use the elasticity of demand to study relationships between changes in price and the changes in demand. Look at this expression right here. This is done using the natural law. This is a different derivation, as you have the derivative with respect to P, where you have the natural log of f of P, which is negative. We got the negative sign here, the relative rate of change of demand over the relative rate of change of price. Now, it's equal to negative with the derivative with respect to P of the natural log of f of P divided by the derivative with respect to P of the natural log of P, which is going to give us negative f prime of P divided by f of P divided by 1 over P, which will give us that same expression right here, negative P times f prime of P divided by f of P. We see that this uses the difference quotient basically to derive the same expression, and we use, of course, the natural log f of P here, differentiating the natural log of f of P over the derivative with respect to P, natural log of P, and we came up with the same thing. Let's look at a problem. Now, if you remember, we had an example from the previous videos dealing with profit function and cost function. And we talked about the equisonic model F, loudspeaker. So consider the demand equation of this example here, where P is equal to negative 0.02x plus 400, in which 0 is less than or equal to x less than or equal to 20,000. Which describes the relationship between the unit price in dollars and the quantity demanded X of the equisonic model F loudspeaker system. A, let's find the elasticity of demand, E sub P. B, compute E sub 100. This is actually E sub P here, but P being substituted, we're substituting 100 here for P, and we want to interpret our results, and then we want to compute, again, E sub, right, this is P, but 300 this time is being substituted in for P, and interpret this results also as well. So for A, the first thing we want to do is we want to solve for X in terms of P using the demand function. So as you see, P is equal to negative 0.02 X plus 400, and as we solve for X here, as you see, very, very, very clearly, line by line, right? Look at that, line by line. We come up with X is equal to F of P, which is equal to negative 50P plus 20,000. Right here, you see that. After we came to this line here, we actually said that X is equal to F of P, which is equal to negative 50P plus 20,000. Now, after we do that, we want to take the derivative of negative 50P plus 20,000. So we get F prime of P to be negative 50. So E sub P is equal to, as we see, negative P times F prime of P divided by F of P, which is negative P times negative 50 divided by negative 50P plus 20,000. And what we did, we have to plug in 100 because we're dealing with A. So we got A. So now we want to compute E sub 100 and interpret the result. So here we're at, after we do this here and find out this is what A is, this is the elasticity of demand here. This is what this is right here. This is A. So we're done with A. So now we're going to B, where we're going to plug in 100 for P. And then when we plug in 100 for P, we get 1/3. So let's interpret the results here, if we will. When we interpret these results, we see that the answer to that problem is 1/3, which is the elasticity of demand when P is equal to 100. To interpret the results here, what we're trying to do is recall that E sub 100 is the negative of the ratio of the percentage change in the quantity demanded to the percentage change in the unit price. Now, when P is equal to 100, that is. So therefore, our results will tell us that when the unit price P is set at $100 per speaker, an increase of 1% in the unit price will cause a decrease of approximately 0.33%. 0.33% in the quantity demanded. So that's what's taking place here. Look at that very closely. So you have 1% of the unit price will cause a decrease of approximately what? 0.33% in the quantity demanded. So, very, very important information. Now let's look at C. We want to compute E when P is 300. We want to interpret our results. So when we plug that in, we say 300 divided by 400 minus 300, we come up with the answer 3, which is the elasticity of demand when P is equal to 300. It tells us that when the unit price is set at $300 per speaker, an increase of 1% in the unit price will cause a decrease of approximately 3% in the quantity demanded. Now, that concludes part 1 of our video. We will talk about part 2 in just a moment. See you in a few.